All right, you are back. And now I was still explaining of how we're going to get O1. So O1, we're going to get it by adding O1 plus O2 plus O3. And this would be equal to 180 degrees because these are the angles on a what? On a straight line. So from there, we then make O1 the formula by taking other angles on the other side, and we're going to have 180 minus O2. We calculated it and we find 90 degrees minus O3 is given, or we calculated it as what? As 30 degrees. Therefore, O1 will be 180 minus 90, which is 90 minus. Therefore, O1 will be 60 degrees. And this is how you're supposed to answer that question. Why did I say this question is important? Because you can see it revises almost all the theorems that you have done in previous grade. So if you don't know this theorem, it could be very difficult. I mean, if you don't know how to answer this question, it would be very difficult for you to answer questions that come in grade 12, because this is just the revision of what we do from lower grades. Let me log this. So yes.
Can you do the cycle without the values, without 8 and 100?
For the what?
Without values, that cycle, without values, like without 30 and 100.
Or 530 and 100. Where is it?
Without the values, just A, B, C, and O.
A, B, C, and O.
Yes, without that 30 and 100.
Right.
Just values.
Okay. Your network is cutting, so I'm not able to get everything you are saying correctly. So try to say it again. Maybe I'm gonna get it now. What did you say?
Can you try doing that cycle without the value of 30 degrees and 100 degrees? Just aim alphabet.
All right. It's not this question that you have on the board, right? Is that what you're saying? It's not the question we have on the board that you are referring to.
You can do that one.
All right. All right. Okay, I'm trying to check.
Hello.
Yes, yes. Can you hear me?
The network is bad.
Yeah, the network is cutting, so that's why I'm not able to get what you are saying.
No.
Yes, yes. I can hear you now.
Can I send you a question paper?
Yeah, you can send the question paper. Yeah, quickly send the question paper and then I will be able to attend to what you're saying. So let me wrap everything we have on the board now. And then we can attend to what you're saying just now. Before I cover the other theorems, quickly send what you want me to do for you. All right. Which question are you referring to here?
You can do any question.
Okay. Okay, but these questions, they involve other theorems that have been covered with you as yet. So let me cover the theorems first, and then I'm going to attend to the questions here. So now let me tell about these other theorems which are important. So this would be theorem number 5. So it's when we are in a circle and a tangent. So we have a circle and a tangent, and then inside a circle we are given a triangle which touches exactly at one point on the circle and also on the straight line. So now, if this triangle is triangle ABC, and then here we have C1, C2, and C3, there is a relationship which is established between angle C1 and the angle A, and the angles C3 and the angle B. So C1 will be equal to angle A, and angle C3 will be equal to angle B. Why is that the case? Let me write here, because we have a theorem which is called tan chord theorem. It's a very important theorem of which you must be able to prove it as well. I will do a proof with you in other lessons. It's a very, very important proof which you must all know how to prove, because it usually comes in the test and exam. So now C1 will be equal to angle A, and C3 will be equal to what? Angle B. Why is that the case? Because we have what is called a tan chord theorem. Then let's quickly go to theorem number 6, of which talks about a circle with let's say we're given A, B, C, D. And then now, this is a cyclic quad because you can see we're given a parallelogram inside the triangle. So we can relate angle A and angle D or angle C with angle B. So now, angle A plus angle D, these two angles, when you add them together, they're going to be equal to 180. Why? Why are they equal to 180? Because we have what is called cyclic quad, which is very important. Cyclic quadrilateral. So the opposite angles of the triangle that you, opposite angles inside the parallelogram, they are equal only if we have a cyclic quad. This is the cyclic quad if all the vertex on the parallelogram are on the circumference. If they are not on the circumference, this theorem does not apply. You must get that right, because it's important that all the vertex of the parallelogram, they must be on the circumference for this theorem to apply. That opposite angles inside the cyclic quad, they are equal to 180 because we have a cyclic quad inside the what? The cycle. Are we all together with regard to that important theorem that I've highlighted just now?
Yes.
All right, let's quickly go to another important theorem of which talks about the angles inside the triangle and the angle outside the triangle. So let's say we are given angle A here and angle B and then angle C. So this angle A will be equal to angle B plus angle C. Why? Because the sum of the two interior opposite angles is equal to the exterior angle. So this is the exterior angle and these at the interior angle. Why do we call this exterior angle? Because this angle is outside the triangle ABC. Do you all see that? That A is outside triangle ABC, but B and C, they are angles inside the triangle. Therefore, the external or the angle outside the triangle, external angle is equal to sum of opposite interior angle. So this is exterior or internal is the same. Let me use the word interior to simplify this. So exterior angle is equal to sum of opposite interior angle. You must not forget this angle. I mean, you must not forget this theorem. It's a very, very important theorem which you are going to use many times. That the angle that is given outside is equal to the sum of the opposite interior angle inside the triangle. And then theorem number 6 is when you are given a cycle, and then inside that cycle we have a cyclic quad. So, but this is not just a normal cyclic quad, because you can see if this is A, B, C, and D, then there's another angle that is formed there, which is outside. So there's this angle here, and then the other angles there. But now the relationship we establish in this case is that this angle we have here is equal to angle C that we have there. So angle A outside the cyclic quad is equal to angle C, which is inside the cyclic quad. Why? Because of the same theorem we have down there. So these are the angles inside the what? The cyclic quad. These are the theorems which are important to take note of. You must not forget even a single time when we answer the questions that I'm going to do with you. So some of the theorems which are remaining here I've done quickly with you. For example, one of the theorem I've done is the sum of the angles inside the triangle, and then the alternate angles, the co-interior angles, and the corresponding angle. I've covered that part with you. So, but now let me also add this important theorem that we have here. So now we are now having two tangents. We have a cycle, and this cycle is having two tangents. So let me call this point A, and then this point B, and then we also have point C, where the two theorems, the two tangents converges. So now this theorem, we are told that the side AC is going to be equal to side BC. Let me use AC here. So AC will be equal to BC. Why these two are equal? Because we have two tangents. Because we are given the two tangents to the cycle. Whenever you are given two tangents which intersect at C or intersect at one point, therefore you must know that the distance from the cycle or to the point where cycle touches with the straight line is going to be the same as the distance on the other tangent. So BC will be equal to AC. Why? Because these two are the what? Are the tangents of the same cycle. So we're given same cycle with two tangents. So I would like to find out if you understood all the theorems that I've highlighted to you just now. Let me quickly check if there's another theorem. Okay, there's this just one theorem I would also like to cover with you, of which will be given a triangle, and then on this triangle there's a line that passes through from the center of the cycle straight to the chord of that triangle, which is this. Therefore, now if here is O, and then here is B, and then here is C, and then that point is D. Just because we have a line that goes from the center of the cycle and it goes to the point D, you must know that if D, this is very important, that if D is equal to 90 degrees, this information is critical, that if D is equal to 90 degrees, then you can say BD is equal to DC. Otherwise, if this is not the case, then BD will not be equal to DC. What are we saying here? We are saying that if here we have a right angle triangle, then BD is going to be equal to DC. It's another important theorem of which you must take note of. You must remember that theorem. So I believe with the information I've given you just now, we can be able to do the question that sent to me just now. Can we do question 4 together? Time is very, very fast. I'm having UNISA class at 7, but let me try to rush through that question 4. So if I'm not able to cover it with these 4 minutes, I can do for you and send it to you on WhatsApp. Question 4. So we are given a cycle and this. Now, I believe there's another theorem you can see. Just after writing that, there's just one theorem which must come into your mind, which talks about the 2 tangents. Né? So here we have D, and then here is B. So because we have 2 tangents, then you must know about these 2 sides here. So DC is going to be equal to what? BC. Are we all together? And if that is the case, there's a line that crosses here. And if that is the case, there's another theorem which you must remember, that if these 2 sides are equal, what can we say about the angles we have down here? We have talked about this theorem many times. If these 2 sides are equal, what can we say about the angles at the bottom there?
They are equal.
They are equal. You must not forget that. It's this information that comes from this theorem, theorem number 9. So DC is equal to BC, and then if that is the case, therefore B is going to be equal to D. That information is on the question you gave me just now. Okay, from there we have a cyclic quad, of which I've given you the information about the cyclic quad. So if we have a cyclic quad, there's another theorem which you must not forget, because this is a cyclic quad, because all the corners of this angle inside the cycle, they are at the circumference. Therefore, the opposite sides of the cyclic quad are equal to the sum of the opposite angles inside the cyclic quad are equal to 180 degrees. So it's another information which you must keep in mind. Okay, my time is moving very fast, but I'll try to explain this question to you. If time does not allow, I'm going to send you the answer for this question on the WhatsApp, and I will try to explain. All right, and here we have 1, 2, 3, 4. All right, then now let's check in. There's another theorem which must also you must remember. So we have a tangent here. Then what can we say about here? We have the intersecting the beats here. So now we have A, D, B, which is a triangle inside the cycle. Then there's a relationship about this angle we have down here with the angle we have up there. If you remember, the theorem is the tan chord theorem. I also gave you the tan chord theorem, which relates this angle we have here with the angle that we have. So we can't talk about this angle because it's not given. So this third angle here, we can't relate it with that one because it's not given. We relate D1 with what? With angle A, not A1, not A2, but angle A for this triangle. So mind about the sides which are given. This we can't talk about because it's not given. Even that we can't talk about because it's not given. You must remember about this which are given. Like here we have A and then we have B. All right, guys, my time is up now. I'm going to another class for UNISA mathematics. So let me send the solution for that question to you on WhatsApp, and I will try to explain where you don't understand. you will have to let me know. I'll try to make sure you understand that question. And again, we're going to meet tomorrow. So I've tried to cover all the theorems for grade 11. So it means tomorrow we're going to do as many questions as possible for the theorems we've covered up to so far. The next time we're going to cover the theorems for grade 12, which are simple. There are only 6. I think by one day we can be able to cover all of them. Okay, for today, let's end here and have a good night.